Thanks very much. I love hearing a crowd of developers cheering for some nerdy talk, so this is my jam. I wanted to do a talk because I want to find public speaking fun. And so I tried to submit a talk last year, and I was umming and ahhing about it. And then I submitted it late, and they wouldn't let me in, because I emailed the organizer, and they were like, look, that wouldn't be fair on everyone else. And I was like, come on. And anyway, I was at the drinks for DDD, and I overheard someone talking about this CTO guy who tried to jam his talk in after the thing, and I was not proud of it, but I didn't admit it was me. I just sort of said something along the lines of, yeah, that guy sounds like a real jerk. Anyway, I got my talk in really early this year, and my friend told me that if you want to get a DDD talk in, it's got to be a little bit cryptic and quite a bit clickbaity, so I think I nailed that. So the talk is on running modern software teams. And firstly, I'd just like to thank our sponsors. Great bunch of sponsors here. Yeah, GitHub, you really don't need to advertise to us anymore. We all love you. It's cool. But yeah, thanks to all the sponsors. Wouldn't be here without you. I'm Matt James, CTO and software engineer. I was the former software engineer and CTO at VGW for a number of years. I freelanced for the last year, and now I'm the CTO at Isotana. I'm married with 2 dogs. I'm an okay tennis player, but a really good coffee maker. And I don't just do software development as my job, but I also have it as a hobby, and that's illustrated by I've done 10 of the ICFP functional programming contests, which run for 3 days. And it's the first time writing that sentence was the first time I realized that I've spent 30 days of my life living off beer and pizza. And I don't know if it's a good or a bad thing. But this talk today is a bit about my time in all 3 of those different roles, but particularly as a freelancer, because I got exposed to a lot of different software teams. Probably about 4 or 5 directly, and indirectly I heard about how maybe a dozen plus teams are running their software teams, and I noticed some common problems. So I thought I'd talk about those common problems. I don't want to be negative about it, because I think we've come a long way. I don't see anyone 10 years ago deploying 6-month release cycles or anything like that. So we have to appreciate we've made massive strides in how we run teams. But as you always do that, there's new problems that come up, and so that's what I'm going to be talking about today. So how I like to think about it is there's things inside the box that we all know and love and we're focused on and we get better at them, and then there's things outside the box. And it's the things outside the box, I think, that need a little bit of work now. So we're getting quite good at CI/CD and DevOps and cloud infrastructure and all these things, and we've focused hard on that, and that's good. We should keep doing that. But also, we need to focus on things like architecture, design, communication, planning, prioritization, judgment, alignment, strategy, these kinds of things. And I don't see as many talks about that, though this year there's been a few more, which is good. I hear a lot around the place, things like, oh yeah, but that's not my job. I really dislike that one, because these are the things that help you write better software, and if you just want to fob that off to the product manager, then I don't think that's a good thing. Also, the teams that I see having an equal say in things like prioritization are the teams that run the best. So I'm going to talk a little bit about these things in the talk today. And if you want any more motivation, then AI is coming for all your jobs, so we need to get better. So I'm not going to tease you anymore. The problem with problem solving is you might not be solving the right problem. I have a tendency as an engineer to just jump straight into the first solution that comes to mind, and I head full ball down a direction, and then only later find out that I should have thought that through a little bit better. So yeah, I have a natural tendency, because solving problems is the exciting part, it's the interesting part, and I love it. And if you leave me in a room without solving a problem, then I probably eat the couch. Why is this important? Well, Richard Hamming, who was a pioneer in our industry, was saying this. So he said, formulating a problem incorrectly sets you off on the wrong path in the first place. So he's talking about, think about what problem you're actually solving first. And he said, it's better to solve the right problem the wrong way than to solve the wrong problem the right way. Because if you solve the wrong problem the right way, you make it wronger. And it's not just about wasting time. So wasting time is one factor, but if you go off in the wrong direction, to get back on the right direction, you kind of have to undo all the work you just did to get yourself back to the start. You may not even realize you're going in the wrong direction until right to the end. There's sunk cost fallacy. You get so far down the wrong path that you're like, oh, I can't go back now. And yeah, but if you solve the right problem the wrong way, at least you can improve and you're going in the right direction. So this is a little bit esoteric at the moment, but I'm going to explain it with some examples. But first of all, why isn't prioritization easy? Like, it should be simple, right? Like, there's only two categories, what we do now and what we do later. So why can't we just nail prioritization? Why does this cause so many problems? Like, the product manager should just tell us what to do now and we'll do it. And, you know, like, it can't be that hard. But actually, it's probably one of the hardest problems that we have because to use an example, let's say we came up with the whole list of the priorities of things to build. We've got all these features that we're going to build and then roll out. And then tomorrow there's like a solar flare or something and the internet goes down. And now like we thought we had a solid plan and a solid roadmap and it's all thrown out the window. Maybe a more realistic example is like Silicon Valley Bank going under and now all your priorities are out the window because your company's going under. Those are extreme examples, but the same thing happens almost every day. You know, there's unknown things that come about that really shift all your priorities and you've got to be able to adapt to that. Otherwise you're stuck going down the wrong path. So key point number one, identify the right problem to solve. Going to use an example from Theodore Levitt. He said, how do we make a better drill? Like, let's say you have an engineering team and your company is building drills. And your CEO comes to the team and goes, hey, you guys, you need to make an awesome drill this year. Off you go. What do you do at that point? Like, you've got an existing drill, you've got to make a better one. Well, the first thing I see teams do is they sort of like break down the drill or they break down their product. So they go, here are the features in the drill. Like, we'll break it down, we'll cut it up into slices and then there's power, precision, battery life, modularity, brand, grip, blah, blah, blah. And then we'll use some kind of like framework, maybe prioritization framework, or we'll do it kind of loosely. We'll just sort of line all these things up in terms of, you know, top being the lowest effort, highest value thing, and we'll work down the list. And yeah, you could use, like I see people using CD3 or some kind of agile prioritization framework. And it's sort of based around this, sort of based around taking your product, breaking it down, or taking a problem, breaking it down, and then sorting all those things into a list. But like I said with prioritization being messy, what about the things you don't know about? So if you just take this is a very like focus on the things you do know about. We know the drill, we know all the features, let's just sort all those. If we did a little research, just a quick Google search in fact, you might find a little bit of information you don't know about. The average productive time of a drill in its entire lifespan is about 12 to 13 minutes. So tell me this, which one of those features should we improve based on the fact that in the entire lifetime, the drill's only used for 12 minutes? I'd argue none of those are really going to make a difference to a customer's life who's using a drill. So yeah, that's one way to go about prioritization, and you can see sort of the problems with that. Levitt then went on to say people don't want to buy a 1/4-inch drill. What they really want is a 1/4-inch hole. And he's saying that all those features are actually, they don't matter. In fact, the product itself is even irrelevant. What the people want is just their problem solved. And how you do it is sort of just like totally up to you, and you know, basically the product being irrelevant means that you can come up with other ways of solving problems. So there's a great way to sort of discover what the customers want by a guy called Sakichi Toyoda, who in the early 1900s came up with the 5 whys, and it wasn't really applied properly until later in the 70s. But the Toyota manufacturing line, you know, you think of a manufacturing business as being quite straightforward, maybe a bit boring, and you're just sort of running things through a line. But what he did was sort of reject this approach of breaking, like if you want to improve a process in the manufacturing line, you just break it down and then improve the parts and put them all back together again. And he rejected that in favor of doing the complete opposite. So he said, well, the first thing we need to do is we need to go and expand our thinking by going to a higher level and finding out or like figuring out what people really want in the first place, or maybe what's going wrong in the process overall. So he came up with the 5 whys. So you go, why do you need a drill? You need to drill a lot of things. What kind of things? Mainly holes in the wall. Why do you need a hole so I can put in a nail? Why do you need a nail to hang a painting? And why do you want to hang a painting in the first place? Because it's no good on the floor. After about 5, it gets a bit redundant. So I think that's why he called it the 5 whys. So yeah, so this is one way to, if you think about it, instead of going down from your product inwards, you're going from the product outwards. You're trying to look out into what's actually driving the forces behind why people use these things in the first place. And he had great success doing this. If you read The Toyota Way, which is a great book, you'll find that actually rejecting this sort of traditional thinking gave them a lot of success in improving their processes. So what people really want is the painting on the wall. In the product design world, you guys might be familiar or not, but this is what's called context. So you're building in this context, and context is sort of a primary thing to think about before you go off and start building something. In fact, it's probably the first thing. Form is the product or the solution that you end up building to fit into that context. And it has, it fits into the context, and how good it fits into the context is called fitness. It's how good your solution is. And affordances are things like the features of it that sort of get shaped and affect the fitness of the product. There's one way to think about it. Akoff said the best thing that can be done to a problem is to solve it. False. The best thing that can be done to a problem is to dissolve it, to redesign the entity that has it or its environment so as to eliminate the problem in the first place. Often this is another thing where if you jump to solutions, you'll end up solving problems that could have been dissolved had you reorganized or rethought the problem itself. So get to the underlying problem. No one even wants a hole in the wall. What they want is just the painting on the wall, and that's why these adhesive companies are doing so well. And if you think about it, the drill companies, the competitor to your drill product is not another drill company. It's actually these adhesive companies now. So this might be a trend that they didn't actually pick up on. And instead of building the next drill, they should have been looking into this. Kind of like Blockbuster with online. Anyway. Okay, to bring it back to software for a minute, I see this one a lot. So it's the classic download button. Someone from the business comes to you and says, can you just put this download button here? It's a small piece of work, let's just do it. And they're not even coming to you with a problem, they're coming to you with the solution. And then you're like, okay, you put the download button in, they can download the table in your app as a spreadsheet. And then 6 months later, they come back to you again and go, we've got a big mess in our Google Drive because we've got all these spreadsheets sitting there now. Can you go and sort that out? So the first thing to do when someone comes to you with a solution is to ask what the problem is. And we used to have a saying at VGW, which worked quite well, which goes, anyone in the company can pretty much ask anyone else who's working on something like, what problem are you actually solving? And half the time they go, I don't really know, I'm just building the thing. But it sort of forced us to focus on it and for everyone to just have an understanding of why we're doing something in the first place. And if you went and talked to the person who wanted it and you asked them about why they want the download button, oh, so I can send the spreadsheet off to someone in finance. And then you're like, well, why can't the person in finance log in and just see it? Oh, well, they're not in the system. Okay, let's just add them into the system. We don't need a download button. So perfect example of dissolving the problem. So how do you know what the actual problem is? Well, you need to go and investigate. And Dan Markovitz said about product development that good investigators visit the crime scene. So This is how you go out and you actually identify and figure out what is really going on and what problem you really need to solve, and to do this sort of expansive thinking rather than inward-facing thinking. Actually, don't ask why questions first, because why gives you all kinds of opinions that you don't really need at the start. What you want to do is you ask what questions first. What do they really do? And if you think about it, this is what investigators do. And a lot of product designers and product managers these days are here talking about how investigators run interviews with customers. And it's all about the facts. You don't want opinions first, you want facts. So first of all, don't make assumptions, like just clear your head of assumptions. And don't lead the interviewee, and ask specific facts, not opinions. If you think about your favorite crime scene investigator, they don't go, hey, what do you think happened? Oh, well, you know. No, they don't ask that. They go, what exactly did you see? At what time? You know, what were you doing? Rather than asking them, what do they think happened, which can lead you all astray. Look into the forces. Why do they need it? Why do they want it? Were they under time constraints? Be specific, like what time, literally what time did you want to use the download button? Oh, well, it was just before lunch and I had to get it off to finance because they were screaming at me down the phone, and you know, you start to get a whole picture. Okay, maybe I'll go talk to the finance person, see why they need it. So once you know all the facts, then you can start to expand. That's when you can do some problem solving and start to invent some solutions. The age-old quote for this is, if I ask customers what they want, they told me a faster horse, Henry Ford. And it's the same here. What you want is facts. What are you doing? When are you doing it? And then you can basically get to the why through that. All right, this is a bit of a busy slide, but bear with me. So when I do product strategy and planning and prioritization, there's really three categories that I think about. First on the left is bottom-up thinking. So there's code we're working on right now. They're related to these JIRA tasks. We identify new problems from the tasks we're currently working on, and then we go and solve those problems. And that's very similar to the example I gave at the start, where you break down the things you currently know about. There's also top-down thinking, which is you start with the end in mind. You start with the customers. What are the customers trying to get done? What can we do to make an impact on that? Identify a set of solutions from that, and then work on those highest impact solutions. And this is also good, but not complete. It's not fully sufficient. You also have strategic thinking, which is sort of more expansive than that. What you do is you start with where your company is currently at, and you go into bigger context. So how does our current company fit into the broader market? What trends and changes are happening that affect that market? What will things look like in 10 years? And then what can we do now that will let us define the future on our own terms? And that applies to a company just as much as a software team, maybe on a shorter time scale. So at the beginning of a quarter, what we do is we start with strategic thinking, make sure we've identified all the things that could really undermine us and what we're doing at the moment, or opportunities in the market that we need to go and jump on and actually should replace all the priorities that we currently have. I was doing this with my current company, Isotana, and the previous quarter we did come up with doing strategic thing. We did come up with inward focus thing on improving product quality. But the next quarter, we've kind of done the opposite. We've identified an opportunity we need to go and attack. At that point, what I then do is I go into a room with the whole product and engineering team, and then we do top-down and bottom-up thinking at the same time. And the reason is, and it is messy, it sounds messy and it is messy, but what we did last quarter was we went and grabbed all the examples of issues with product quality, or any feedback that we've gotten from customers on issues with product quality, and we put that in one list on the right. Then we identified all the things that anyone suggested throughout the last quarter on how we could improve our product, and we put those on the left. Now, obviously, we can't solve every problem on the right, and we can't implement every solution on the left, but putting those two things side by side, you can then synthesize what would be the biggest impact thing on the left that would have the biggest impact on the right. And it sounds messy. There's no formal framework that I know of that really does it this way, but I found this quite effective and efficient. It doesn't take too much time. Probably the planning time into that, before that session, is where most of the time is spent actually pulling all those customer examples and pulling all those ideas from the team. is probably the most time-consuming part. I just keep notes on all those things throughout the quarter. All right, so entertain me a little bit. I know this is a little bit philosophical, but I wanted to sort of, I was interested in understanding where this analysis thinking came from. So analysis is where you break down problems into smaller parts and then you solve each part separately. And analysis was the dominant thinking through the Industrial Revolution. And what happened when machines got introduced is they would break everything down, every piece of work, down into what's called elementary tasks. And then the machine works only on elementary tasks by applying energy to matter. And that's the definition of a machine. Sakichi Toyota found success in completely rejecting the analysis way of thinking for synthetic thinking, for example, the 5 whys, where you start by expanding out rather than looking inwards. But what I see is we still believe in treating developers like machines. We are breaking down work into elementary JIRA tasks and feeding it to developers on a manufacturing line, which I thought was quite funny having read about this history. And determinism meant we believe by breaking things down, we can have a perfect understanding of our problems. Similar to our belief following frameworks perfectly will achieve perfectly running engineering teams. And I think I've illustrated that that's just not the case. But I still hear a lot of people saying things like, if a roadmap has changed, oh my God, the person who planned that roadmap didn't do their job properly because the priorities changed. I hear that a lot, and I think we need to kind of appreciate the fact that there's so many unknowns, there's dozens of those unknowns out there, that almost certainly the priorities should change because with better understanding, we should keep updating our priorities. Have you ever heard the saying, the plan is worthless, but planning is essential? I think that's what they meant. Like, the plan is going to change, and so it's not a perfect plan, but the act of planning helps you identify all these unknowns. Yeah, so analysis and synthesis, you can read more up on this, but I'm not going to go too much into it, but there's actually 3 steps in each, and if you read the steps, they're the complete opposite of each other. So analysis is breaking down the problem, and synthesis is looking at your problem as part of a larger context. We've been through this, but there's some theory you can read if you want to. I found Now Next Later, a product manager I work with closely, Sarah, actually introduced me to this. It was invented by Jana Busto from ProdPad, and she said that I invented the Now Next Later roadmap because I believe that rather than focusing on deadline-based delivery, product teams should stay focused on discovery, which I think fits in well with what we've been talking about. This is sort of working with the complete acknowledgement of our own ignorance, the complete acknowledgement that we don't know everything and that things need to change. So you have 3 groups now: well-defined problems we're currently working on; next, problems we know are important and currently being planned, scoped and understood; and later, hazier longer-term objectives not yet well understood. And the appreciation in the team is that the further to the right you go, the more likely those things are to change. So you're still putting them down, we're still doing the planning, but you're saying the plan is probably, well, things in the later column are definitely going to change. Things in the next column may change. But at least it gives you some idea of what's coming up. So I think this works a lot better than really rigid roadmaps. Key point number 2, fight for simplicity. I think the other issue that we have often is we spend so much time talking about really awesome tools and better ways of doing things that we forget about probably the metric of simplicity, which is also an important one to focus on. It may not be as interesting, but it's an important one. My favorite snooker player, Ronnie O'Sullivan, said this quote, and I think it applies really well to software development. If you play a lot of simple shots well, you rarely have to play a difficult one. And this applies to software in that if you just do a lot of simple things really well, then you rarely end up with a situation where you have a really hard technical problem to solve. And if you do, it's probably a good one where it's related to the business problem that you have. So we all know, we've probably seen talk about this, that there's two types of complexity. There's essential complexity and accidental complexity. And essential complexity is just core to your problem. Like, you can't get away from it. You have to solve this in order to solve your problem. And accidental complexity is basically everything else. So anything we introduce that is adding complexity to our lives, that isn't actually solving the core problem. So if you think about it, accidental complexity is a choice. We choose to do these things because of some trade-off, which may be a good trade-off, but it's still accidental complexity because it's not core to the problem. And I think we mix these things up quite often. We go, no, it is essential because we have to do this, but really it's not. I think the goal should be to reduce the accidental complexity down to the least surface area possible. And if you are choosing to introduce complexity, it really has to 5x that complexity in terms of value that it's adding. Classic cartoon. Can you pass the salt? I said, I know, I'm developing a system to pass you arbitrary condiments. It's been 20 minutes. Yeah, I know, but it'll save you time in the long run. It's, like, even people who know and love this comic probably still do this. This is a good one as well. Super simple code on the left, years of programming experience. So as you get sort of a couple of years programming experience, you learn all these design patterns, object-oriented programming, and functional programmers like spruiking their wares. And you get peak complexity after a few years where you get abstractions and interfaces. I might need this later. And then after a lot of years of programming, you're like, I'm just going to do the simplest thing possible to get my job done. Look, I wasn't going to include this, but I recently read some of the new Musk book, and I'm not going to read every part of this, but it's just direct copy and paste out of the book. But although I hate a lot of his management style, I do agree with some of his points here. Question every requirement. Number 2, delete any part or process you can. You may need to add them back later. In fact, he says, if you don't end up adding back at least 10%, then you haven't deleted enough. Simplify and optimize, and then accelerate cycle time. So look for efficiencies at that point. And only 5, automate. So only at the end, after you've fixed your process, do you automate it. Because once you've automated it, it's really hard to change it. Microservices, like, everyone is doing microservices these days, and when I ask people why they're doing microservices, I get a range of different answers. The first one will be performance. Probably hear that one quite a bit. We need to scale things independently or separately, and they have different performance requirements. Almost always I find this not to be the case. One thing is dominating the performance requirements, and the other thing wouldn't really make an impact on it if it was deployed together. Large code base, that's an easy one to falsify because we can see there's a lot of large code bases that work just fine with good modularity. Best practice? I don't know. I don't think so. Manage complexity. This one as well, I think that, again, it's such a trade-off that either you're managing the complexity or you're introducing more complexity than you need. Look, this might be my limited number of sample points that I have, but the only good reason I've seen to do microservices is when you're scaling teams. But the only examples I can think of where it's been successful and it's introduced less complexity than the value it's adding. I think Amazon was the first to do this, so as far as I know, don't quote me on it, but they released, or Bezos released a paper saying, everyone's to use APIs. Every team is a service, and you expose APIs, and if you don't like it, you can leave. And what he noticed was, or I think what they noticed was, as they introduced a new team in the company who had to communicate with basically every other team in the company, the more teams you add, the exponential the communication lines get. And the thinking at the time, around 2007, was that we should improve communication, we should improve alignment, we should employ communication practices and frameworks and teach everyone. And this approach is really like, no, let's have no communication between teams. It was enforced as a rule. The only communication was through APIs. And I think this was a successful one by the looks of it. So I think that's where independently deployable services come in. I see a lot of people saying, oh yeah, but I can split the repos and now the code's more manageable. Well, that's just a different folder. And now you have twice the deployment work. Well, then they say something like, yeah, but if we abstract the deployment work, then it'll be quicker and easier. And to me, that's the passing the salt argument. It's like, if we just abstract it, it'll be easier. All right. I see a lot of this. So we've got 4 microservices. They're all talking to each other. And because we've named them differently, like they're decoupled. And it's like a, I don't know, DDD best practice or something. Bounded contexts are good, but just because you can name things differently does not mean they're decoupled. Let's say we change these lines so that we made the line thicker if there's more requests going to it. And if we saw this, I see this a bit, where every request coming into B also goes to D. And 99.9% of all requests in the system are going to B and then going to D. And people say, oh, but it's decoupled because we've named them differently. And I just think, no, this is completely coupled. And I think this is, to me, this is a good argument because of network coupling to keep B and D together. This certainly isn't performing well if you're doing this. Choose standard and simple tech. Why do you need to? Because I see a lot of new tools coming out and maybe they're more efficient and they can help you do things better. Sometimes that's true. I'm not gonna say otherwise. Sometimes new tools live up to their hype and they really take off and they are the new and greatest way of doing things. Oftentimes though, you have limited innovation tokens, which means you've got a limited capacity to spend time innovating. So if you're spending time on very low level tools and innovating on those, you're probably not gonna have time to innovate on your actual business problems. Simple tech is often the most flexible. For me, that's just a SQL database when I start a project, or maybe even SQLite. And only when that sort of runs out of, or hits its limit, do I switch it out for something else. And I also think don't be an early adopter, be part of a large community. There's so many times I see people hitting bugs that they have to solve in some tool. That's total accidental complexity. If you choose a tool that has millions of people using it, then basically if you've hit a bug, almost hundreds of thousands of people have already hit that bug and it's already been fixed, it's sitting on a PR ready for you to upgrade to the new version. And the popular tools are not necessarily best, so don't just follow the hype. Again, some things do really live up to the hype, but you can think of a whole sort of cemetery of things that don't. Angular might be one of those, or it's, the people who say choose the right tool for the job end up with a lot of tools to manage, I think. Yeah, so I saw this, was helping a team out, and it's a small team of 10. And looking at how anxious everyone is after what I've just been talking about. So I did this, literally just got a hacksaw and got rid of a bunch of queuing things, databases, a bunch of extra services that were deployed on different types of technology, different programming languages. And remember, this is a small team of a dozen people or so. So yeah, there was mix and match of different tools, of different databases, and basically we were able to do this. And we also cut a bunch of environments out, and we ended up with 3, which was later staging and prod. And to me, you can probably get away with 2 until you have real customers who really need you to be a bit more rigorous, and then 3 is probably my ideal. So I'm a real minimalist, and maybe I'm getting a lot of disagreement, but that's my bias towards minimalism. And so we ended up with that. I don't know, I see people sharing their architecture diagrams and sort of bragging about how complicated it is, but I'm doing the opposite. So you've got a performance problem. Some web requests are taking a long time. Let's just add a remote cache like Redis. The issue I have with this is it's so expensive to add a new component to your system. You've got to learn how to manage it. You've got to learn how to maintain it. It introduces a lot of other things like consistency. What if the consistency of your data is out of sync between your apps, the Redis cache, and your database now? So you've just introduced a whole set of distributed computing problems that you didn't actually have before because everything was consistent in your database, hopefully. Probably not. More consistent. It's more consistent. So yeah, the cost of adding a new element is often ignored. It's so easy to add it though. Like the cost isn't straight away. You can add it in easily. It's the overhead over the next 5 years that is the real cost. And so it looks so easy to deploy, but then people don't have the foresight to see all the cost and overhead of maintenance that's introduced. And besides, who really has a serious performance issue anyway that you need 1 million transactions per second cache? Well, I mean, it's a good question. Like, let's take Amazon, for example. Number of orders per second, peak load. Millions? Anyone millions? Raise your hand. Hundreds of thousands? Thousands? Hundreds? I think, obviously they're doing a lot of other requests, but the peak load that I read, it's just Google, but I read it was 600 orders per second. So how many transactions per second are you really doing? And what's the capability of your tools? Have you actually measured how many transactions per second your database can do? It's probably around 50,000 on a regular old laptop, on a SQL database like Postgres, sitting in Docker or whatever. 50,000, that's more than enough for almost everyone. So if you have a performance problem, it's probably not your tools. You probably don't need a new tool. You probably need to refactor your code a bit. So there's a bunch of, please stop. Non-remote cache solutions you might find. Fix slow queries. Often it's just a query that was not written, or you just need to introduce an index. But we've added a cache and introduced all this complexity when your query was slow. Reduce your data size in the database. Optimize your schema. Fix complex and messy read-write process application logic. That's probably slowing things down, but you can't tell. Use a local cache. A local cache works just fine in most cases. As opposed to a remote cache, and you have less maintenance because you don't have a new tool. There is more, so I would prefer the top 4 things first, but if you're really desperate, then a local cache probably suits all the other use cases. Or you can put your servers closer to your users if you're hitting a latency issue. I might get some disagreement on that, but that's my opinion. I like to do this exercise sometimes. It's called idealized design. So what I like to do in my head or sometimes in code, let's say we have a simple problem. We have a collection of name counters. A is 10, B is 15. We want to be able to do some following operations: get a counter's value, increase or decrease counter's value, move a counter's value from one counter to another. And some simultaneous requests operate on the same counters. So this is the problem, and you've got to solve it. Now, let's think about accidental and essential complexity. What is the essential complexity of that problem? Oh, the code doesn't look great there, but idealized design on the left, you can't read the code well, but it's in Python, and it basically does what you think it does. It just has the counters in a dictionary, and you've got some functions to move the values around. To me, that is the essential complexity. Now, a lot of people would take that code, I think, and then do enterprise to-do list. Where you sort of draw an architecture for what a to-do list should deploy to. And to me, that's all the essential, the accidental complexity. But the reason why you should do idealized design is because it gives you some relativity to how far you are away from the essential complexity and how much accidental complexity you've introduced. And on the right, I like to think, what if we didn't need any of the accidental complexity? And this is the sort of problem to take home, is could this be done without any other code, without worrying about database transactions, without worrying about database, HTTP, or other semantics? but still with ACID and linearizable guarantees, good performance, local run, test and replay, live production debugging, and fast deployments to production. I don't know anything that does this at the moment. You have to write it yourself. But to me, this was sort of the overarching goal of the serverless movement and community, is to remove all that accidental complexity. And although I like serverless and it's great in some ways, I feel like it hasn't quite lived up to my expectations on removing all that accidental complexity, because it's introduced a few new problems as well. So yeah, idealized design is a useful tool to help you set your mind on what is the minimal possible solution. So key points: identify the right problem to solve by looking outwards, then top down, and then bottom up. It's messy, but give it a try. Use the 5 whys and investigate problems like a detective. Fight for simplicity and prefer removing rather than adding system components. Think of removing one as a +5 points and then adding one as a -1. And you'll make better trade-offs. And try to fix bottlenecks before adding a cache. And don't do microservices until you're ready. You really need to scale your teams up. That's it. Thank you. We've got 4 minutes for questions if anyone would like to ask one. Just wait till the microphone gets to you. And sorry, I also saw the guy behind had his hand up, so we'll go to him next. Sorry, the girl at the front first. Yeah.
Thank you very much for the presentation, and it's really good to see talks on solving the problem and strategy and so on. I've really always liked the idea of the now, next, later roadmap that you presented, exactly for the reason that you said it allows you to focus on the problem instead of, an agility. The problem I've seen is that stakeholders don't really like it as much because it doesn't provide as much detail. Have you had that same experience, and can you maybe talk to us about how you overcame that? Or
Yeah, that's a great question. That is the friction point, I think. And I have experienced it firsthand in the company I'm working at the moment, and also VGW. I think if someone expects a really detailed, you can do detailed, but the key point is that it may change. So if they want detailed and cannot change, that I think they're off on the wrong track there. Like, they don't understand that that's impossible and you're going to get a worse outcome that way. So yeah, it's sort of like friction that can't be solved unless you have the conversation and you explain why things do need to change, because it's better for them. And if they knew how it was better, then send them to my talk on YouTube later. A good question. All right.
Yep. Hi. Thanks for the talk. It's been great. My question is about the prioritization stuff that you've talked about. That was really valuable. Do you have any more sort of reading materials that you can suggest? I feel like there's so much focus on like tech and all the inside the box stuff you talked about.
Yeah. Good question. I probably should have put some references at the end. Bob Mester, one of the best product minds I know. I've read all his books. He's a sales as well as a product guy, but don't let that put you off. He's a really good thinker, and all the stuff he's worked with the likes of Basecamp, but he also worked in Japan with some of those methods as well. He's got a wealth of experience. Really interesting guy, and his videos are excellent for an overview, and he's got some books as well. So Bob Mester is that guy. Basecamp do put out a lot of interesting things. I feel like they've got a really different perspective on software development because they're mostly designers. So they're coming from the design angle, which is, I've sort of ripped off a little bit of ideas from them in this talk. So Ryan Singer, who wrote ShapeUp. ShapeUp describes prioritization as making bets. They have a betting table, they don't have a roadmap. So yeah, some of the ideas align with some of that, and ShapeUp's a great book to read to give you a bit of an overview from the design perspective as well. Yeah. Anyone else? Chris.
This is going to be the last question.
Last question.
Hey Matt, thanks for the talk. That was really enjoyable. With the synthetic thinking, like thinking about the context as opposed to just jumping straight in with the analysis, do you find that ends up with you not needing to do analysis at the end of that, or do you feel like it's a way to just get a better direction, but that you sort of need to do the analysis at the end when you actually do something about it?
Yeah, you need both. Yeah, so at different times. So the synthetic thinking is for working out what problem to solve in the first place. Once you've got a problem and you're like, how do I solve it? Analysis works really well. And that's the top and bottom up thinking. And you do those at the same time. And that's essentially what you get. So synthetic thinking will give you the why. And the analysis will give you how to solve it. Yeah.
Thank you.
There's another great, you should listen to Akoff on talking on that. He's got a really interesting perspective, and he talks in detail on that stuff. So go check him out. Thanks.